Equivalence relation we are discussing here, equivalence relation. Now I am taking one example. It is an NCERT example. That is, let T be the set of all triangles in a plane with R is a relation in T is given by. So R is defined T1 and T2. T1 is congruent to T2. So that R is an equivalence relation. As already we have discussed the reflexive relation, then comes to define the symmetric relation. You can take any two triangles. Okay. You can take any two triangles, that is T is the set of all triangles. This is the set of all triangles. Clear? एक प्लेन में बहुत सारे ट्रायंगल्स हो सकता है. We can take any two triangles. And these two triangles are congruent to each other. That means T1 as by any four rules, SS, SS, RHS, whatever it be. You find out that T1 is congruent to T2. If T1 is congruent to T2, these two triangles are said to be congruent, then T1 and T2 belongs to this relation. T1 and T2 belongs to R. Clear? If T1 is congruent to T2, definitely T2 is congruent to T1. Then T2 or T2 is congruent to T1. Hence T2 and T1, this order pair also satisfied this relation. Hence R is in symmetric relation. As per symmetric relation condition, it will satisfy the symmetric relation. Then comes to transitive. We can take any three triangles here. T1, T2, let it be T3. Belongs to T. T is the set of all triangles. And from these three triangles, you can take any two triangles. That means T1 congruent to T2. Already defined T1 is congruent to T2. That means T1 triangle T1 is congruent to triangle T2. Then again T2 is congruent to T3. T2 is congruent to T3. As T1 is congruent to T2, ये दोनों बराबर हो गए ट्रायंगल. T2 is triangle to T3, T2 T3 के बराबर है. Then definitely T1 is congruent to T3. For implies T1 is congruent to T3. That means T1 comma T3 belongs to R. Okay. Now it will satisfy the condition of transitive. Hence R is in transitive relation. Okay, write down. R is in transitive relation. Then comes to, if that relation satisfy all three relations, that means reflexive, symmetric and transitive, then the relation is said to be equivalence relation. अगर इसमें कोई भी एक रिलेशन सेटिस्फाइड नहीं करेगा तो दैट मीन्स रिलेशन आर नॉट इन इक्विवेलेंस रिलेशन. क्लियर? अब देखो लिखना क्या है, राइट डाउन. As R is satisfied, as R is satisfied, reflexive, symmetric and transitive, then R is in equivalence relation. R is in equivalence relation. Clear? Okay. Then comes to the next example. Next example, question number 2. Okay, let L be the set of all lines in a plane. Okay, all lines in a plane, and RB the relation defined as R equals to L1 comma L2 such that L1 is perpendicular to L2 so that R is symmetric but neither reflexive nor transitive. Look at here this question. Okay, that means this relation is not in equivalence relation because it is not satisfied all three conditions. But you have to show that at any cost R is in symmetric but neither reflexive and nor transitive. How it can possible? Look at here, first goes for reflexive. Okay, that means L be the set of all lines in a plane. You can take any line. Let L1 belongs to L. We can take any lines in a plane. Can every line is perpendicular to itself? कोई भी लाइन के ऊपर रह गया. If a line here L1, you can take another line also L1. They are coincident to each other but not perpendicular to each other. That means every line is not perpendicular to the line itself. That means L1 comma L1 does not belongs to R. It does not belongs to R. If L1 comma L1 does not belongs to R, that means this other pair is not satisfied. That means it is not satisfied the condition reflexive. Hence, R is not in reflexive relation. Then comes to symmetric. Second one is your symmetric. अब हम सिमेट्रिक रिलेशंस डिस्कस करेंगे. देखो, now in the case of symmetric relation you can take any two lines from the plane. Let L1 comma L2 belongs to L. You can pick out any two lines. Okay, now look at here this diagram. This is L1 and this is L2. Now L1 is perpendicular to L2. Let L1 is perpendicular to L2. That means L1 comma L2 belongs to R. As your relation defined, L1 is perpendicular to L2. You can take. Can L2 is also perpendicular to L1? Yes or no? L1 is perpendicular to L2. That means the angle between two lines is 90 degree. Yes or no? Angle between these two lines is 90 degree. We cannot change L2 and L1 others angles. the same angle represented by L2 and L1. That means L2 is also perpendicular by L1. Hence L2 is also perpendicular by L1. Then L2 comma L1 is belongs to R. That means it will satisfy the condition of symmetric. Hence R is in symmetric relation. R is in symmetric. Why? Now L1 is perpendicular to L2, then definitely L2 is perpendicular to L1. Clear? Then comes to the third condition. Now reflexing does not symmetric happens. Okay, as per your proof, so that R is symmetric, R symmetric हो गया, but neither reflexive nor transitive. Reflexive नहीं हुआ, proof कर चुके हैं हम. Then goes for transitive condition. Okay. Third one is your transitive. Transitive के लिए क्या करना है? How many elements you require to take? At least 3 elements. As per your question point of view, you can take any 3 lines. L1, L2, L3. तो देखो मैंने ऐसे डायग्राम बना दिया. This is L1, let it be this is L1, L2, L3. Let L1 is perpendicular to L2, let L1 is perpendicular to L3. Okay, तो ऐसे एक डायग्राम मैंने लिया. Look at this condition. L1 is perpendicular to L2. Clear? As per your diagram. Then L1 comma L2 belongs to R हो गया. नहीं, relation satisfied as relation is given. L1 is perpendicular to L2. Then again L1 is perpendicular to L3. Can L2 is perpendicular to L3? Now L1 is perpendicular to L3. That means L1 comma L3 is belongs to R. But L2 is does not perpendicular to L3. That means L2 comma L3 does not belongs to R. That it is not in transitive relation. आप उसको अलग तरीके से भी लिख सकते हो. L1 L2 L1 comma L2 belongs to R. L2 comma L3 it does not belongs to R. Hence L1 comma L3 belongs to R. तो 3 कंडीशन में एक satisfied नहीं हो रहा है. That means it is not in transitive relation. Clear? So as per your proof, it is clear. Okay, symmetric but neither reflexive nor transitive. Then move to another example. so that the relation are in the set one, two, three given by R equals to 1, 1, 2, 2, 3, 3, 1, 2, 2, 3 is reflexive but neither symmetric nor transitive ये क्वेश्चंस दिया डिफरेंट वे में, यहाँ पर रिलेशंस सेट्स फॉर्म रोस्टर फॉर्म में दे दिया है नहीं, हम उसको चेक करेंगे. इट इज रिफ्लेक्सिव बट नीदर सिमेट्रिक एंड नॉर ट्रांजिटिव. देखो एलिमेंट्स कितना दिया है हमने रिफ्लेक्सिव पॉइंट ऑफ व्यू. Reflexive. How many elements are in the present in the set? 1, 2, 3. You can take any element. Let 1 belongs to A. Let us consider the set A. Okay. If 1 belongs to A, then 1, 1 does not belongs to or belongs to R. देखो 1, 1 इसमें है या नहीं है रिलेशन में है. Then 2, 2 belongs to R. Clear? 2, 2 भी है. Again 3, 3 that is belongs to R. 3, 3 B. Clear? That means all 1, 2, 3 elements it will satisfy as per your reflexive condition. Hence R is in reflexive relation. Then comes to symmetric. देखते हैं बेटा सिमेट्रिक हो रहा है ना. सिमेट्रिक के लिए तो हम दोनों अलग एलिमेंट्स लेंगे 1, 2. लेट 1, 2 बिलोंग्स टू R. 1, 2 बिलोंग्स टू R है उसके अंदर सेट में है. क्या 2, 1 बिलोंग्स टू R? क्वेश्चन इज अराइज. ढूंढो वहाँ पे 2, 1 ऑर्डर पेयर कहाँ पे नहीं है, तो ये क्या हो जाएगा? डज नॉट बिलोंग्स टू R. हेंस R इज नॉट इन सिमेट्रिक. R is not in symmetric relation. Then comes to transitive. अब देख लेंगे 1, 2 है relation R because present in the set of relation. 2, 3 belongs to R. It is also present in the relation. क्या ना 1, 3 or implies can 1, 3 belongs to R? Question arise. Can 1, 3 belongs to R? देखो इसके अंदर है नहीं है. That means does not belongs to R. It will contradicts the condition of transitive. That means it is reflexive but neither symmetric nor transitive. Clear? As we have discussed many examples, you should also learn about what is equivalence relation, how to find, how to show, and how to show reflexive relation. Okay, how to show transitive relation. Then we will discussing about your exercise. Okay, 1.1. There are many questions are given. If possible to solve all the questions. Is there any doubt? You may record me. Okay, clear? Thank you.